All right, so today we want to look at a very important topic in trig, where what we call cofunction, like having two functions working together to find a missing angle or missing side, so of a right triangle. So we call cofunctions. And if you want to make this very specific, we could say complementary angles of complementary angles. Complementary angles of using what the cofunction is simply the cosine function and the sine function. So we're looking at the relationship between these two. Let's go right ahead. Now we have a right triangle like this, and if we were to remember, let's try to remember the total degree of a triangle. The total degree of a triangle is 180. Now this side is 90. And so these two must, if we were to find the degrees of these two missing angles, let me give you A and B, then these two must add up to give you the remainder after taking away this 90 from that, give us 90. This 90 is sharing between these two. So that 90 degrees is sharing between these two after you would have subtracted this 90 from that, the total degree. And so the idea of this thing is that these are complementary angles. So the complementary angles are two angles or angles, that's not two angles. But when you add these angles, they give you a total degree of 90 degrees, which makes a lot of sense. And so we can assume, let's say, so if I have B and I have A, and I say, okay, this side is 90, then this side, these angles, one could be 45 degrees, 45 degrees, or it could be 10 degrees and 80 degrees, or it could be 70 degrees and 30 degrees. But at the end of the day, both should give you 90 in summation. So let's try to understand the concept of using the cosine and the sine function as a relationship in solving for missing sides and missing angle of a right triangle. Now, if I were to label these dimensions by giving them 3, 4, 5, and I say, want to look at this carefully. If I were to write this angle in regards to using the sine function, I would say sine A and the sides that are associated with the sine function are the opposite divided by the hypotenuse. If I were to use this as a in terms of the cos function, would say cos B, and we have what the adjacent divided hypotenuse. Now, if I were to substitute the ratios or the dimensions of the sine rule, I would get sine. I'm gonna replace this for A. Or I don't have to do that. I could let this thing. You could have A, and we could have what up in terms of sine, this will be the opposite side, while this is gonna be the hypotenuse. So we say the opposite is 4, hypotenuse is 5. If I were to use B in terms of cos, remember the ratios or the sides that are associated with the cos function is actually if we're going to use this for the cos terms of cos, this will be the opposite side, and so this will be the hypotenuse side right here. No, the adjacent side right here, while this is hypotenuse side. And so if I were to substitute the dimensions for or the ratio of this cos function, I would have cos B is equal to the adjacent, which is 4, the hypotenuse, which is 5. And if you look at these dimensions or these ratios, we realize that they are the same. So with that, we could actually rewrite this in a sense that we could actually do something like this. I need some more space. So I could see it then. Sine, if they are the same, they equal the same ratio, the ratio or the sine. So I could say sine A, we could say sine A is equal to cos B in terms of the ratios, huh? And not only that, since also what we realize is that uh uh angle A plus angle B should also be 90 degrees. If you were to draw this again, remember these are complementary angles. Angle A plus angle B, angle A plus angle B must be equal to 90 degrees. So the thing is, if I wanted to find the value of one of these angles, how could I find it? Very, very simple. Now that's where you see the cosine and the sine function uh work together in terms of connection or relationship to see how we could find it. Very, very simple. Now, let's use about the same dimension that we used. If I wanted to find this angle in terms of sine and this angle in terms of cos, let's see. We could do this so many ways. Let's do this. Let's do it step by step. Now, if I say find the value of sine A, and then find the value of cos B. Very, very simple. It doesn't matter which one you want to find first. You want to find sine A or cos B, it doesn't matter which one you want to find. But since A is the first letter in the alphabet, let's find A. Let's find A first. Very, very, very simple and easy. Now, let's do this step by step. So let's find A. Find A in terms of the sine function. Now remember that the dimensions or the ratios, the ratio of the sine function is hypotenuse divided the opposite divided by the hypotenuse, or the opposite over the hypotenuse. Let's substitute this dimension. Now we're going to substitute this for that. The opposite side here is going to be 4. Hypotenuse is going to be 5. So I would say sine theta is equal to 4 divided by 5. And now we want to find theta. That's what we really want to find. That's A. We want to find theta. So if you were to divide this, we would get sine theta is equal to 0.8. We want to find the theta, so we could just divide both sides by sine and by the laws of indices. If you remember, once you have a fraction, it's going to be rewritten in a different way. So I could just do this like this, sine. Oops, let's go back right here. So if I cancel this, theta is all by itself. Sine is going to turn to the inverse while I have 0.8. If I were to press this in my calculator, if I say sine inverse 0.8, theta, which is A, would be equal to 53. If I were to round this out to the nearest tenth, I will get 53.1. That's just A. Now remember, if I want to find B, I could find B in 2 ways, or even more, but let's say at least 2 ways. Remember that A plus B, let me say, can I get some space here? If you remember that A plus B they must add up to 90 degrees. They are complementary angles. So remember that sine B, or it doesn't matter. It doesn't matter which one you want to say, sine A or sine B. Let's say, let me just do this right here. Let's say sine A plus cos B should equal to, when you work them out, angles, they should give you 90, which is the same thing that this is saying. Same thing. So we just found A, which is the first angle in terms of the sine function. So A was what, 53.1. We want to find B. We don't know what B is. We're going to find it. We subtract both sides by 53.1. And if you look at this cancels that cancels that. B is going to be equal to 36.9. And if you were to add this and add this, well, you actually get the 90 degrees of their complementary angles. So that's one way to find one of the angles after you would have found the first one. Let's see how we would actually, let's look at another way to find B. Now, we just found B. A is what? 53 point that. And let's say we don't know what B is. Another way we could find B, we could use this, we could find B the same way we found A. The same way we found A, the same way we could find B. Remember that. Remember that the cost function with this angle share the same dimension or ratio as the sine. Remember, so or remember that they share the same. And if we don't, if we are not sure, we could just rewrite we could relate the dimensions. Let's say if I want to use this in terms of the cost function, let's see which dimension would be we will be using. We will be using to find to solve for A, solve for B in terms of cost. Let's look at this. Now, if this is the reference angle for the cost function, this would be the opposite side. Remember that the two sides that are associated with cos is A over H. This is H, this is A. That's opposite. So we only need these two sides. So we could rewrite this as B is equal to 4 divided by 5. Adjacent, hypotenuse. When you divide this, we get the same thing. We get what? Cos B is equal to 0.8. Now, when we do that, let me get some space right here. Get some space right here. When we do that, we realize that we have what? Cos theta is equal to 0.8. So if I divide both sides by cos, that cancels that. That is equal to this. We got the inverse function. All right. And if you were to plug this in your calculator, you would have gotten 36.9 degrees. So you could have done that so many ways, so many ways, so many ways. So let's try to do a couple more questions. Let's say I have cos let's say 23, and I want to find let's say the angle of this. What would be angle A if angle B is that? Now remember, they both must be added to 90 degrees. So I could simply say, 23 plus A is equal to 90. And that's not the shortcut of, that's just the whole essence of this thing. They should be, when you add them, they should be 90 degrees. So if I subtract 23 from that side, A is going to be equal to 67 degrees. So A is going to be 67 degrees. And if we don't, and we could even prove if this makes any sense. Let's say if I wanted to see what sine 67 sine 67 is 0.9, let's say 92. Let's see what this would be. Let's see what that would be. Let's see. 23 cos. We get the same thing. So that simply means there's some relationship between these two. So let's even do another one to just see how many questions we could actually, solve in light of this concept. If I say find if sine B is equal to I don't know, say 3 Let's just do something very simple. Let's say 1/2. What would cos A be? What would this be? What would this be? Very, very easy. We always try to do, we need to find the value of B. Once we find B, then we subtract it from 90 and we get this. Very simple. Let's see what this would be. So if I just write this in a shortcut, I would have B be equal to sine inverse divided as a fraction, as a decimal, we have a half. Right? So let's see what is sine a half. So 0.5 inverse sine. We get 30 degrees. Then by default, if you were to find A, we could say A plus B should give you 90 degrees. What is B? B is 30 degrees. If we subtract 30 from 90, we get 60 degrees. And so A would be equal to 60 degrees. This should not be taking you guys like a minute to solve. It's very simple. Let's look at something let's look at another question. When we have uh an equation looking like this. Let's say sine, or the angle is theta plus 20 is equal to cos, let's say 2 theta plus 10. And I want to find the value. Let's say find the value of the theta. Find the value of theta. Now we just want to find the value of this theta right here. Now we could actually treat this as an equation, just as you would have you have an algebraic equation. Now, always remember that these two at all times should always be added and be added and equated to 90 degrees. So let's look at this. Very, very simple. So we treat this as A, we treat this as B. We say A plus B is equal to 90 degrees. So A is going to be theta plus 20. B is going to be 2 theta plus 10, and we equate this 90. This is so simple. This is like an equation. You're actually finding the value of x. So we group the like terms. So when we group, we have 1 theta plus 2 thetas give us 3 thetas. Three theta, or what you want to call it, 3 degrees. Not 3 degrees, three thetas. So we have 20 plus 10, that gives us 30. And we equate this to 90. Now, if I were to subtract this 30 on both sides, I will get 60 degrees. Right? Let me clear this up right here. So we got 3 theta is equal to 90 minus, let's say, 30 degrees. Theta. And when I subtract that, I get 6 degrees. If I just divide this by 2, divide by 3, my answer would be, if I were to just simply, let me equal to 20, right? That's 2 right here. Theta is equal to 20 degrees. 20 degrees. Okay, so we could even prove if this makes sense. We could try to see if when we add everything, if it give us 90 degrees. So we had what? We had what? Theta plus, what was it? 20 degrees plus 2 theta. 2 theta plus 10. I should prove it that these two are actually 90 degrees. When you add them, give you 90 degrees. So what we had for the theta, we had theta is what, 20. So everywhere we see theta, we're gonna put 20 there. We get 40 for right here. 2 times 20 is 40 plus 10 is 50. And then we got 50 degrees, 9 degrees. And so there you go. Looking at the complementary angles of in regards to a relationship with the cosine and the sine rule in finding missing angles. So there you go. Stay tuned for more. Please remember to subscribe and share. I'll see you next time.